In this video, we will learn how to assign oxidation numbers to different atoms within a molecule. So let's start with rule number 1. Rule number 1 states that for elementary substances, the oxidation number of any uncombined element, whether it be monoatomic, diatomic, or polyatomic, its oxidation number is always 0. Moving on to rule number 2. Rule number 2 states that for monatomic ions such as the sodium ion, which has a single positive charge, its oxidation number is equal to the charge on that ion. In this case, that will be +1. Another example is chlorine with a negative charge. The oxidation number of chlorine is equal to its charge, which is -1. Calcium, which has two positive charges, its oxidation number is +2. For rule number 3, we will use two examples. We will use a neutral compound and a polyatomic ion. So this rule states that for all the elements that are present in a neutral compound, the sum of their oxidation numbers is equal to 0. So when we add the oxidation numbers of copper, sulfur, and these four oxygens, the total oxidation number will equal 0. And for a polyatomic ion, the sum of all the elements, the oxidation number of all the elements that are present within that compound, their sum will equal to -2. So when we add the oxidation numbers of these four oxygens and this sulfur, the sum will equal to -2. For step number 4, we will simply memorize some useful oxidation numbers for two atoms, hydrogen and oxygen, because their oxidation numbers remain consistent for most compounds. The oxidation number of hydrogen is +1, except when hydrogen is bound to metal hydrides, which are represented by this X. So metal hydrides are all the atoms that are present in the first two columns of the periodic table. So we must know that all the atoms that are present in the first group of the periodic table, their oxidation number is +1. And for all the atoms that are present in the second group of the periodic table, their oxidation number is +2. So whenever hydrogen is bound to a metal, its oxidation number is -1. For example, if hydrogen is bound to sodium, which has an oxidation number of +1, the oxidation number of hydrogen will be -1, so it's able to balance out the charge. But when hydrogen is not present in a metal hydride, its oxidation number is always +1. The oxidation number of oxygen is -2. Exceptions include hydrogen peroxide. In hydrogen peroxide, the oxidation number of oxygen is -1. We know that the oxidation number of hydrogen is +1. There are two hydrogens in this molecule, so the overall oxidation number of hydrogen is +2, and the oxidation number of -1 of oxygen just balances this out. Another exception for oxygen is when it's bound to fluorine. When it's bound to fluorine, so fluorine is present here in the periodic table. As fluorine is more electronegative than oxygen, so the electronegativity of compounds increases as we move across the periodic table. Fluorine is more negative than oxygen. It is able to attract electrons better than oxygen, so it leaves a positive charge on oxygen. So in this case, when it's bound to fluorine, the oxidation number of oxygen is +2. Another exception for oxygen is when it's bound to superoxides, such as for the superoxide anion O2 minus. This is a superoxide anion. Its oxidation number is half. But outside these cases, the oxidation number of oxygen is always -2. Another rule that we can remember is the oxidation number of all atoms that are present within group 7a of the periodic table. Their oxidation number is -1, except when they are bound to atoms which are more electronegative as compared to them. For example, let's consider chlorine. When chlorine is bound to hydrochloric acid, its oxidation number is -1. But when it's bound to oxygen in this compound, its oxidation number is +1. As oxygen is more electronegative than chlorine, electronegativity increases as we move across the periodic table and also as we move up the periodic table. Another rule that we may also remember is that aluminium, its oxidation number is always +3. So this video is followed by other videos on how to calculate oxidation numbers and how to identify redox reactions. But